Okay, so to finish this problem, to do part C of the ladder problem, what we first need to figure out is what are they asking us to find. All the when and the given is the same, and I'm going to go ahead and just kind of clear that out so we can look at the problem. So find the rate of the at which the angle between the ladder and the ground is changing. So the ladder and the ground is this angle right there. And so what they're asking us to find is d theta over dt. Okay, so the when and the given, I'm not going to write that down, but the equation we got to come up with. So last year in pre-calculus, you did a whole semester of trig where you related angles and sides and angles and all that kind of stuff. So we have options. We could use sine, cosine, or tangent. On some problems, one of them is going to be easier than others. Like, let's just say we had not done part A. Let's just pretend we hadn't done part A, and I don't know what dA over dt is. Okay, well then I probably wouldn't want to pick sine or tangent because both sine and tangent, the opposite is A, and I don't even know dA over dt. Okay, in our case, we found dA over dt. We were given dB over dt. And what is dC over dt? The rate of change of the ladder? Zero, because the ladder is not changing, right? It's not getting taller, shorter, or longer, or anything like that. So in our problem, we know everything there is to know about A, B, or C. So we could really pick sine, cosine, or tangent. There's not one that's really, I think, easier than another one. So I'm going to go ahead and just pick sine. But again, we could pick another one. You do need to be consistent. Make sure you're using your SOHCAHTOA ratios. Opposite over hypotenuse, that's going to be A over C. Okay, so let me go ahead and rewrite it. Sine of theta equals A over C. We could have chosen a different trig ratio, and then these letters would have been slightly different. We had that option. Okay, so take derivative of both sides. Derivative of sine of theta is cosine theta times d theta over dt. Just like on all the other problems we did, anytime we took derivative of any variable that wasn't t, we had to write d, that variable, over dt. And that's important because that's actually what we're trying to find. So if you forget this, you're not going to be able to answer the question. Okay, what about the right side? That's a fraction. Quotient rule. Okay, so derivative of the top, dA over dt, times the bottom, so times c, minus for quotient rule, the top times the derivative of the bottom. All over the bottom squared. Okay, so what you want to do real quick is make sure that you can find all of these things, because if you can't, then maybe pick a different trig. All right, but we're good in this case. We know what all of these things are. So cosine of theta, you need to remember again, SOHCAHTOA, cosine is adjacent over hypotenuse, so we're going to put a 5 over 13 in its place. The d theta over dt, that's what we're looking for, so I'm just going to rewrite it. The dA over dt, that's what I found in the first part. C is 13, A is 12, and you guys just told me dC over dt is 0. So again, if there's any of these that you don't know and you can't find them, then maybe pick a different trig and start over. Okay, so you either need to just use your calculator and do something like this, divided by 5/13. This really isn't that bad to do by hand though, because watch this, the 12 and the 0 cancel out. Divided by 5/13, that's the same as 13/5. And then look what happens. There's a 2 13s and the 13 squared, so all you're really doing is negative 1.25 divided by 5. And so what you should get, however you want to solve that equation, is negative 0.25 or negative 1/4. So that's how you're going to do these angle. Anytime they're asking about the rate of change of an angle, you're going to need to use sine, cosine, or tangent. And some of the times one of them is a better to do than another one. You have a couple of those in that homework assignment.
Do you want us to put the degrees?
So we're going to put radians, and then this was seconds, right? Yeah. In calculus AB, we're always going to deal with radians. The only time we'll ever discuss degrees is when we're talking about temperature of something. Never with angles and degrees.
But why did we use a theta for radians?
In pre-cal, your teachers helped you know when to use degrees and radians by saying theta meant degrees, x meant radians. That's actually not a rule. Theta just means angle, and x just means angle. It was just a convention that we use here to make sure that everybody knows which one we're supposed to be in. Good question. Okay, so that kind of wraps up what I meant to cover yesterday. You needed to know this in order to do a couple of those homework assignments. Okay, we're not ready to do cones yet, which is what we talked about earlier. What I want to do next is some shadow problems. Okay, so turn the page over. We'll see how far we get. Hopefully we get through at least all of number 4. I think we will. Okay, and like I said, after the quiz tomorrow, whatever we haven't done in this packet, we're going to try to get through tomorrow, and then Tuesday we'll wrap it up. Okay? So both of these have to do with a person walking away. It could be walking towards a light source, and then why is that control shift thing there? That's weird. There we go. Well, whatever. And they have a shadow. Okay, so what we need to do is we need to draw a picture. First, here's my light source. It's not pretty. You do what you need to do here. Do they tell us how tall this light source is? 18. Hold on just a second. 18 feet. So label that 18 feet. And then we got this guy. They told us his name is Hank. Something's happening. Okay, so here's Hank right here. And again, you don't have to draw a picture, but Hank is in relation to the light. And it doesn't look like a right triangle yet. Until we get to what happens next. So he's walking away. So I'll put a little arrow. He's walking away from the light source. They tell us how fast that is. We'll put that in our Fuigi in a minute. And he has a shadow. So if the light source is over here to the left, where is his shadow at? Yeah, down over here. So there's his shadow. And if you connect the top of the light source to the top of Hank's head to the tip of the shadow, that gives us a right triangle, and in fact, it gives us 2 right triangles. Okay, and they told us that Hank is 6 feet tall. All right, now before we do the next part, I want to show you something that I do that I think makes these shadow problems easier. Okay, there's really 3 distances down here. There's the distance from the light post, or the light source, to Hank. I'm going to call that F because that signifies how far he is from the light source. And you're going to see that language a lot. He is this far, or how far, something like that. Okay, this is his shadow. We could use S for shadow, but that's going to get confusing because there's 2 things having to do with the shadow. If you notice, parts A and B tell you. One is how fast is the tip of the shadow moving, and one's the length of the shadow. So let's call the length of the shadow L instead of S. And the tip of the shadow would be represented by this T. The tip of the shadow would be so far apart from the light source. T could also stand for total. All right, you can use any letters you want here. These are just the letters that I'm going to use when we do these. Okay. So let's continue our Fuigi. What are we trying to find in part A? Determine how fast the tip of the shadow is moving. D Which one of these three letters? Capital T. Now, if you're like, ooh, I don't like that there's two T's here, it really usually isn't a big deal because, like, we're saying dt over dt, but when you read that, you can obviously tell these are different letters that mean different things. You could use another letter besides T. I find that is, as long as we point it out, it's not too bad for most students. Okay, the when, that's all in the picture, kind of like what we did yesterday. You could rewrite it if you wanted to. Okay, what about the given? So there's one thing that they gave us, this 4 feet per second. That is a speed or a rate. I can tell by the units and the language of the problem what's changing at a rate of 4 feet per second. df over dt, how far he is from the light post. So df over dt. On these types of problems, all of your rates are going to have to do with f, l, or t. Okay, so then we get to our equation. All right, now there's no like formula really, but what do you notice about these two triangles? And I'll kind of even, they're similar, so they're proportional, right? So what I can do is I can set up a proportion, and I'm going to do that. Okay, I'm going to say that the height of the big triangle over the base of the big triangle, 18 over t, is equal to the height of Hank, 6, over the base of the little triangle, L. Okay, notice F is not in here. Okay, we'll deal with that in a minute, but this is just the setup of the proportion. We could have set it up with T over 18 and L over 6, and then there's other ways we could have set it up. It won't matter because I'm about to cross multiply. But before I do that, I need to make sure I'm dealing with the letters that I'm given. So see how I'm looking for dt, and they gave me df. Okay, so I like the t right here, but the L I need to replace with something else. Okay, so the L I should replace with what? T minus f. Can somebody tell me, like, on a different problem, like part B, for instance, we like the L because length of the shadow, but we maybe want to replace the T. What could we have replaced the T with? F plus L. So it's not about like memorizing when to do what, it's just setting up the same proportion and then adjusting it to your problem. All right, so I'm going to rewrite my proportion, 18 over t equals 6 over t minus f. And I could derive right now, but what would I have to do? Quotient. Now, if there's no way to get out of quotient, no big deal. But I can actually really make this a lot easier. Okay, so I'm going to do that. I'm going to cross multiply. Okay, what I'm doing now is not because I have to, it's because it makes the thing easier. So I'm going to go 18 times t minus 18 times f equals 6t. Now I don't have any fractions, so obviously it's going to make it a little bit easier. And I can even do a little bit more. I can combine the two t's. So I'm actually going to subtract this 6t over to the other side to get 12t. And I'm going to add 18f to the other side. It just makes it a little bit easier. Could I do anything else to make it easier? I could divide both sides by what number? 6. So we could do that. I'm actually not going to do that because since we have a calculator, that's really not going to help me too much. But you could do it. Okay, not a big deal either way. So let's go ahead and now take the derivative of both sides. And I'm going to write this over here. So derivative of 12t is going to be 12 dt over dt equals 18 times df over dt. And I didn't fully write my given over here. Did you guys notice that? What did they get? They gave us df over dt, and that it equals 4 from right here. I didn't write it over there. Okay, so I'm looking for dt over dt. That's going to equal 18 times 4. And then the only thing you need to do to solve from here would be to divide by 12. And you should get 6 feet per second. And that's your answer. So there's a little bit more setup on these problems, but the deriving part is actually pretty easy. Okay, so let's use the same context of this problem, but then do it for part B. So what are they asking us to find in part B? Yeah, d what over dt? dl, the length of the shadow. And this is why I use F, L, and T. You can really use any letters you want as long as you know what they stand for. So my equation is still going to start out as 18 over t, big height over big base, equals little height over little base. And I'm going to say, okay, I want L, so I'm going to keep L. Do I want to keep T, or do I want to switch it? Okay, so some of you are saying switch and change. I could replace T with what? F plus L. Okay, that would be okay. But what did I just find in part A? I found out what dt over dt was. So it's actually, on this one, totally fine to keep it like this. We do need to cross multiply, though. We still need to do that. So I'm going to go 18L equals 6T. In this case, we don't need to like move anything over. You could divide both sides by 6. I don't really think it makes the problem that much easier. And so now we're ready to derive. So we've got 18 dl over dt equals 6 dt over dt. Remember, we're looking for dl over dt. So keep that as it is. dt over dt we just found out was 6. So I just need to divide that by 18, which is 2, and I'm good to go. So 2 feet per second. Okay? All right, let's see how far we can get on 5. So we got a man who's 6 feet tall. I'm not going to actually draw the picture of a man. And we've got a light post. And how tall do they say that thing is? Number 5, 10 feet, right? So we set it up, and this is what your triangle looks like. Again, you can continue to draw the pictures if you want. These are little right angles. These are obviously similar triangles because all the angles are the same. And then we have F, L, and the whole thing is T. You can think of T as the tip of the shadow or the total. Okay, what are they asking us to find in number 5? So they kind of changed. At what rate is the extremity of his shadow traveling? They could have said the tip of the shadow, right? And so that's a dt over dt. When you're talking about the length of the shadow, that's going to be L. When you're talking about like where the shadow is, that's its distance from the light post. Okay, the when, everything from the picture. What else was given here? What equals 3 miles an hour? D what? A man whose height is 6 feet walks under a lamppost at the rate. So the man is walking. So and it's walking away. So DF. And that's a common thing for them to give, because if you think about a real life situation, if you were measuring something, you'd be measuring how fast the person was walking. And that's going to be 3 miles per hour. Now, I do want to kind of point out just real quick that we have feet and we have miles here. Because of the proportions, we can change them or we don't have to. Okay, so I'm not going to change them, but I'm going to explain to you as we get into the problem why. So remember our equation is just going to set it up first. 10 over t equals 6 over L. And then we're going to decide, do I want to keep t and L or do I need to change one of them? I need to change the L because I have an F here. I need to change the L into t minus F. Sometimes you change the L to t minus F. Sometimes you change the t to F plus L. It just depends on what they give you. Okay? And what you're trying to find. All right, so if we changed, well, hold on real quick. Let me rewrite this up here. 10 over t equals 6 over t minus F. If we changed the 10 and the 6 into miles rather than feet, wouldn't I just be doing the same thing to both sides of an equation? So it's actually totally fine to not change it in this case because it's proportional. All right, so we would cross multiply 10t minus 10f equals 6t. Combine the t's on one side and put the 10f on the other side. Take the derivative. We're looking for dt over dt. So in place of df, I'm going to plug in 3, and then I'm going to divide that thing by 4. I believe this is 7.5, and it is in miles per hour. You've got to stick with the units that they gave you for the other speed.